Hello, Mr. Aaron, Mr. Ryan. How are you today?
Good.
Good. Okay. So today we talk about interesting problem which is called combination sum. So look, given a few numbers, unique positive numbers, yeah, unique positive doesn't include zero, yeah, positive it doesn't include zero. So 1, 2, 3, but it's unique. Let's say 1, 2, 3, 4.
5, 6, 7.
No, that's it. There are 4 numbers. So you can think
They
of.
have to be 4 numbers.
No, it can be any. Let's say.
They need this.
Yeah. Let's say. You have a few items. Which item? These are the weight. Yeah. How much it weight? How heavy? Yeah. Weight. Unique items.
Is
Weight.
it like 1 kilogram?
Yeah. 1 kilogram, 2 kilogram, 3 kilogram, 4 kilogram. Yeah.
I'm like 30 kilograms.
Okay. So yeah. And then I have a bag, a knapsack, yeah, a knapsack, yeah. What's knapsack? A bag, yeah. Knapsack, yeah, a bag. Okay, this is a bag. I don't know how to put a bag. Bag, yeah, yeah, right? A bag.
Yeah.
Some item. A kilogram, 2 kilogram, 3 kilogram, 4 kilogram, yeah. Okay. Now a bag. No, I'm just saying these are items. Okay, and then a knapsack. Let's say the knapsack can be packed with at most 4 kilogram. 4 kilogram. Yeah.
How much you can?
How much? 4 kilogram. This bag can hold
2.
4. Wait, not yet.
Wait, are you allowed to choose more than once?
So these are the weight of different type, but you can have unlimited number of the items for the 1 kilogram.
Okay,
2
that will
kilogram.
be easy. 1.
Yeah, we're done. Look,
Easy
1,
peasy.
1. Okay, this is 1. Okay, can I have 2? 1, 2. Right? Because all these add to the 4. Right? 1 plus 1 plus 1 plus 1 equals 4. 1 plus 1 plus 2 equals 4. Right? Any others? 1 plus 3 equals 4. Yeah? And I can just choose 4. Yeah?
Yeah.
Or 2 plus 2 equals 4. 2 plus 1 plus 1 equals 4. Look, this is different. This is different than this. Yeah, different order, okay? And what else?
1, 2,
3
1.
plus 1 equals 4. Can you think of any more?
1, 2, 1.
1 to 1. Is it 1 to 1? Yes, 1 to 1. 1 to 1. So, do we have 1 to 1? 1 to 1. How many? 1, 2, 3, 4, 5, 6, 7, 8. Oh, yes? Yes, 8. Any more? Any more? Okay, how about let's start.
Okay, 1. No, I just need.
Any more? Can we have
I
any more?
don't really.
No?
No. I don't really think anymore.
Yes. Okay. How about let's see we don't have any of these 4. Okay, so make it easy. Okay, just like that. Okay. We don't have this item 4, so we just have 1, 2, 3, 3 items. 3 items, and we want to come up with the solutions to pack up to 4, right? So that's 1, 2, 3, 4, 5, 6, 7. Okay? Yeah, does it make sense? Look, 1, 3 and 3, 1 are different. 1, 1, 2 and 2, 1, 1 are different. Alright? Eric?
Yeah.
So look, so you're given this input 1, 2, 3 and then 4 target. You need to tell me it's 7. Any idea how we're doing this?
Brute forcing!
How do you brute forcing? Come on, how do you brute force? How do you brute
Check
force?
every.
But the thing is that look, this type of item, you can have a limited number of times. How are you going to brute force?
So you.
How are you going to brute force?
So.
So, kind of, we can backtrack. Backtrack. Depth first search with backtracking. Look, for each item, I can choose. I can choose to pick the next item. For next item, I can choose pick this one, right? Or not pick this one, right? If I pick this one, I can again pick this one until it's bigger than the target, right? So, yes, am I right?
Does it have to equal 4?
Yes, it has to be equal 4. If it equals to 4, then I increment the answer. Does it make sense? So look,
Yeah.
so Eric,
Neighbor?
look, this constraint is that these are unique positive. What happens if there's 0? If there's 0, it will be unlimited number of times combination, right? Because you can put 0 and 0. You put 0, 0, 0, 0. There will be unlimited number of combination, am I right?
Yeah.
And how about negative numbers? Look, if it's 1 and minus 1, there are 2. And then you want to sum up with target 0. How many possibilities? It will be unlimited, right?
1 minus 1.
Yeah, and then you can add 1 minus 1. And you can add 1 minus 1. Do you get it? So it will be 1 plus minus 1 plus 1 plus minus 1. You can keep adding that. And then that's another combination, right? So it doesn't make sense. So that's why we say it's unique positive. Alright? Alright? Okay, so for coming back this is to the brute force, kind of brute force step first search. For each item, we are picking. For the next item, I can try to pick this item, right? If the total weight is still less than the maximum weight we can take, right?
Yeah.
And then what's next? If I pick this one, I can keep picking this one, right? Until it's more than that. Or I can start picking the next one, right? Alright?
Until.
Okay, so let's try a pseudocode. Okay, let's try a pseudocode. But it's very inefficient, right? Because you keep trying until look, yeah. That Eric, pick, yeah. Pick, okay, pick. We want to pick from the numbers.
Whee!
And let's start from the picking the index, yeah, from the I. Yeah? Let's say from I, and then currently we need to pick the target, right? Right? Yeah, target. And then we have a answer. We have count answer currently equals 0, right? Am I right? Okay, so now look, Eric. T is the number of total weight we still have to pick, right? Now look, if T is 0, what do? We increment answer plus equals 1 and return, right? Does it make sense? Yeah? Look, if there's nothing to pick, if the bag it has empty space left, right? Empty weight left, right? Yeah? T is the weight.
We're doing true.
No, we increment the answer, right? Does it make sense, Eric?
Mm.
Okay, then we can start from let's make it left. Okay, so we have this 1, 2, 3. At the beginning we start with 0, index 0. Okay, so now we can say for I in range left. Yeah, we still can pick the left and what? Till the length of nums. Yeah, length of nums. Okay, and then now what? Look, and now what do we do?
Can't see.
Eric? If nums I is the weight of this item is smaller than or equal than the target, right? Right? It means we can pick it. Then we can do this one. We can do this pick what? Pick I. Yeah. Pick nums. Okay. And then we can still picking this number. And what?
Right.
And then T minus nums I, right?
Right.
Right?
Right.
Well,
Nothing.
look, if this item is smaller than the target, then we can pick it, right? We can pick it, right?
Yes.
Alright? Yes?
Yeah.
And then we need to. Then that's it. And actually, that's it because I will be iterating from left to right, right? If it's smaller, right? If it's smaller, T. Pick T, and then the next iteration, for example, left plus 1, you will pick it. You will need to pick it, and then right.
Yeah.
Yeah. So that's it. So look, this is called the backtracking. Yeah. So So it's very you simulate the process. You
It's
simulate.
really fancy.
Yeah, it simulates the process of picking, right? For each one, you can pick or not pick, right? You can keep picking until it's more than it's 0, or look, if it's not 0, then I have to say, look, do I need to check if it's more, if it's less than 0 or no? If you can't pick it, if I can't pick it, that's fine. But look, if you don't check this, what happens? If you can pick, when this could be negative, then you say here, if t is smaller than 0, then return, right? Right, return, right? Because you for I in range I try to pick, but it's smaller. It means that this current item is more than the remaining weight, right? Capacity of the bag, then I need to return, right? Yes. All right. So look, this is the in global counter. We will only increment the answer. We will only increment an answer if t is 0. It means that we have packed exactly t weight, right? All right. The target, yeah.
Yeah.
Okay. So this is one solution, but let's do another solution which is better. Remember what have we talked? We learned before. We have learned before. So, alright. So how about if I say f function fn is the number of solutions combination that we can pack item n, right? We pack the weight n. Listen, it's allowed. So So I have numbers. Like 1, 2, 3, right? Right, 1, 2, 3, these 3, yeah. So look, Eric, the fn, let's say f4. Remember, this target is 4, right? So I want to know f4, right? I want to know f4, right?
Yeah.
Is it equals to the sum of f4 minus 1 plus f4 minus 2 plus f4 minus 3? Does it make sense? Yeah? Look, because f...
24.
Yeah, look, Eric, look. So I want to get the total item to 4, but I know I have 1, 2, 3, right? So if I get the if I have the last item I put, if it's 1, then I have this solution. If it's 2, it's like this solution. If 3, it's this solution. Is it like climbing the stairs? Remember we have talked about the climbing stairs, yeah? The first one you can jump 1 step or 2 steps, right? Yeah? Remember? Yeah? And you want to reach the end step. Then how many ways can you do it? You can think of this the last way. In order to reach the step n, you can jump to the n minus 1 step and n minus 2 step at a time, right? Yeah? There are 2 possibilities. If you want to reach n from here, if you want to reach n, then how many possibilities the previous step? You can jump on the n minus 1 and n minus 2, right? And then once here, you can jump 1 step or 2 steps. This is the same, backwards, thinking backwards. So in order to pack the weight 4, I can pack the last one, which is 1, or 2, or 3, right? As long as it's smaller than the weight. And then I can add this solution. And look, these, we can keep doing this, right? And then we can remembering. So how many ways we can do this? What's the approach what's the algorithm we can use to solve this kind of problem?
Note.
What's this? Yeah, notebook. What's that? What's the algorithm start with D?
The one start with D.
There are 2 kinds of this kind of algorithm, and the one you would like to.
I log in.
No. I'm not saying the complexity. I mean saying the.
Deficit.
No, D. Remember, we use the notebook thing to remember. Like, there are 2 ways.
Wait, I mean memorization.
And what's that called?
Dynamic program.
Dynamic programming. And how many ways of doing that?
2.
2.
Yeah.
And what's that? What's the
Top down and bottom up. And
Yeah.
top down is you normally using the catch. And
Yeah,
how you
catch.
use it memorization.
Okay, good job. Yeah, remember this.
Yeah.
So look, in order to do this fn, I can do it as sum up. Yeah, this is do the sum. Sum fn minus I. Yeah, this I is from the numbers. Yeah, from the numbers. Yeah, am I right? And f
Yours.
n is 0 if n is smaller than 0,
Wow.
right? Yeah, because negative, there's no way. If n is negative, fn is 0, yeah, because there's no way. Fn, f0 equals 1, yeah, because you got nothing. There's one solution to pack nothing, right? Alright? Alright? So this is the recursion. This is the dynamic programming transition function. Do you recall?
Transition
Yeah?
function.
Yeah, and the terminal condition is fn is 0 if n is smaller than 0. Because there's no way to pack negative weight. Am I right?
Yeah.
And f0 is 1 because there's only one way to pack nothing. Yeah? If you have an empty knapsack, that's only one solution, right? Yeah? Does it make sense? Yeah? But remember, the items are unique positive, right? It only works for the unique positive. If it has negative, it doesn't work, okay? So let's talk about the top-down first. Yeah? Top-down is easy to implement. Okay?
Cash.
Define
Cash.
fn. Okay?
Cash.
Column cash.
Cash.
Okay. Yeah. Remember we put the cash. If n is 0, return what?
One.
1. Come on.
One.
If n is smaller than 0, return what?
0.
Return 0. Okay. Then we going through these numbers. Yeah. For I in numbers. Yeah. Remember? Then let's have answer here. Right? Answer equals 0. Answer plus equal f. F what? Can you tell me F what here?
N minus I.
Well done, yes. And return?
Return.
Return what? Come on!
Oh,
Yeah. Does it make sense? Okay, stop jumping, okay? So here, look, remember, we're climbing the stairs to N. And we can, every time, we can climb the steps in the numbers, yeah? It's like we can pack the items in using these items in different items, right? Right? And then how many ways are doing that? So we add it all together and return answer. And what's this cache doing here? What's this cache doing here?
To remember.
To remember, because we are calculating these f numbers, yeah, over and over again. So this is top down because in order to calculate fn, we need to calculate fn minus all the items, which is smaller. This is top down, right?
Yeah, and without the cat, it'll be exploded little whatever you say.
Exponential, okay?
Okay.
Exponential, the complexity. But
Explanation.
with the cache, the fn, with cache, the numbers f0 to fn, we only calculate each number f function only once, right?
Yeah.
So what's the time complexity of this one?
O-N.
Um,
O-1 or O-N?
maybe it's not obvious. Look, we have a 4 here, and we're doing this. So it's the same as look. N is the target, and let's say this is t. Okay, ft. T. Okay, let's do this. Maybe it will be easier.
O-N.
T. Okay, t.
Okay, then O-N something to do with T.
O t times the length of the numbers, right? Length of numbers.
O-T
Right,
length
doesn't it?
numbers.
Because t, we need to calculate t, ft, f0, f1, f2, f3 until ft. Yeah, that's for sure. Yeah. For each one, I need to iterate numbers here. That will be length of numbers. Does it make sense? Yes.
Yeah.
Okay.
You're gonna rub out one.
Okay. Let's do another one. Bottom up. Yeah. So in order to calculate bottom up, which value we need to
One.
we need to calculate it first. We also calculate the f.
Yeah.
We calculate from the f0, f1, f2 until we get a ft. Am I right? Yeah. This is called.
Fine.
Okay. Can I have your attention, please? Okay. Look. Define.
I will.
Let's say. Let's just say f function. Okay. F function we have nums. Okay. And I have a target. Yeah. Target.
How about this? Column.
Okay. Let's go. Look. We have the bottom up. We need to store these f functions in an array, right? Let's call it dp array. Okay. Then look, n is length of nums, right? Alright.
Yeah.
So this dp array is it size of n or size of t? Alright. Eric, I'm asking you, Eric.
So
So
T.
T, yeah, because we want to know the value dp0, dp1, dp2 until dpt. And the result is in which value?
The moon.
The result is in which value? dp equals 0 times t plus 1, okay? Because we want to get the dp value. So the result is in which value, Eric? The result is in which value?
DP.
dp which value? The first value or the last value?
It's the
dp is the, look, it's the f function, right? It's the same as the f function. So dp what? dp what? The array dp0, dp1, dp2, dpt. Which one is the value we are looking for?
we're looking for the
dp what?
0.
Come on, dp0 is the way to pack
Did
empty.
you say T at 1?
Not t at 1, t, because dp t plus 1 is that the size of the array is dp is t plus 1, but we are actually using dp0 to dpt, right? So there are t plus 1 elements. So the result is in dpt, which all you can do is dp minus 1, right? Remember?
Yeah.
The last element, okay? Now the first one, dp0 is actually 1, right? We're talking about, right?
Yeah.
We need to, yeah? Yeah? Does it make sense?
Yeah.
Because there's only one way to pack empty bag, right?
Yeah.
If you put nothing in your bag, that's one solution.
Yeah.
Then now for I in range. In range what? The first direct is 1 to t plus 1, yeah? We want to calculate dpi. From I will be from 1 to t, alright? Alright? Inclusive. And we need to
Inclusive or
J in numbers, yeah? We want to iterate all the numbers, items in the numbers, yeah? The different weight. Then if I is bigger or equal to J, what does it mean? We can pack J in a bag, right? Yeah? So dpi plus equal what? dp what? Can you tell me?
DPJ.
A little bit close. Okay, I want to pick this is the, I want to calculate dpi. And then now I find out that the j, we can pack the j in the bag. So what does it equal? Remember f4 equals f4 minus 1 plus f4 minus 2 plus da 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 da. So this n is I, and these are the item.
0 to J.
What's 0 to J? No, come on. I what? This is the I
minus.
Keep going. I understand it, not remember. What?
Oh yeah, wait. I minus the 1 up to J.
What do you mean?
T.
What do you mean? I'm 1 minus J. I have a for. Look, for loop. J in numbers. If I.
J.
Huh?
T.
Sorry?
T plus 1.
Don't guess, okay? Don't make a guess. Understand. I want to pack this item J. So how many? What's the way I need to increment it?
J.
Yeah, J. Come on.
That's
Oh,
what I said.
How high will that be? And then look, return what? Return what? Can you tell me return what? Return which one?
DP.
DP what?
I said DP.
DP what? Come on.
The last one, minus 1.
Give me answer.
I minus.
T. Yeah, T. You can put a T or minus 1 is the same thing, okay? Yeah? Because T is the last value, minus 1 is the last value. DP0 is 1 because there's only one way to pack the empty knapsack. And we want to calculate the value, dpi from 1 to t. For each one, I need to calculate. I need to iterate the numbers, yeah, the numbers of different weights in the items. If current bag has capacity to pack item with weight j, then the solution must be added dpi minus j, right? Yeah, because I already packed this j, then I need to take the j out of the maximum weight I, right? Does it make sense? Eric, remember the climbing the stair. Fn equals Fn minus 1 plus Fn minus 2, right? Or if you can, Fn minus 3, if you can walk 1 step, 2 step, or 3 step at a time. If you want to climb up to n stair, So the previous state would be minus 1.
Boo.
Yeah, you have.
Boo.
You are here. This is the top. You can go to the here, go to here, or go to here. After reaching these 3 steps, you can all jump to the here, right? Am I right? So that's the number of ways to reach the item state n. It's similar. I want to pack the item up to weight n, and I can pick one item, pick all the item j, yeah, numbers. If this number is 1, 2, 3, right? And you iterate the numbers 1, 2, 3, and you'll be the same as fm minus 1, fm minus 2, fm minus 3. J will be 1, 2, 3. Does it make sense, Eric? Does it make sense? Do you get it?
Quite sorry.
Sorry, what kind of? Which part you not sure? That's okay. Ask me questions. Come on.
Okay.
You need to understand. Ask me questions. We've talked this similar problem before, right?
What's the time complexity?
The time complexity here it's easy to see. Look, t and length of I, right? Remember, OT, length of lumps, yeah? That's what the complexity. Sorry?
What is space?
Good question. What's the space complexity?
Looks like it's
Oh. There's no n here. O what?
a 1.
Oh yeah, there's an n here. Is it O-N or O what? O-O-T. Come on, which one?
T.
O-T. Come on, be confident. Because we're only using this dp, which is size of t, right? Yeah? Which is size of t. Okay?
Yeah.
Okay, ask me one question. Come on, I answer it. Ask me one question. You need to ask me questions, then I can answer it.
Okay. So why did you teach this today?
Good question, because I want you to learn. Another question, come on.
Okay. So why did why did the oval?
Come on, ask question, come on.
Sir, why are they kind of messy?
You have asked your turn already, come on.
I got lots of I don't really know what to ask.
You don't really know what to ask? So you understand everything?
I don't know what to ask.
You understand everything, huh?
Not really.
Not really, no why you ask. You don't understand and you don't want to ask. Huh? So which one you think you will remember it? You understand it better? The top down or bottom up?
I think top down.
Top down. This is bottom up, right?
Yeah.
This is bottom up is the reverse thinking, but top down is the straightforward thinking. The only key thing is remember to use what?
Cash.
Cash. Okay. Okay. So can you
At the right time.
yeah can you tell me how to write? Let's revisit the top down. Okay.
Cash.
Okay.
Cash.
Define
Cash.
F
You forgot cash.
N. Okay. Cash. Okay. Can you tell me what to write? Come on. F N what? So tell me what to write. Fn is the number of ways to pack up the items.
So it's like, I think it's like...
If we know the...
It's like something big equals like 0. Blah.
If what? If what? And what? Equal what?
0.
Then
Good.
return what?
1.
Yeah, and if what? We need to check if it's smaller than 0 and return what?
0.
Okay, and then now we have an answer. We want to return this answer, which is 0. And what should we do? We should iterate the numbers. How do we iterate the numbers? Come on. For what?
4.
For what? I in
Rain.
nums, yeah? Okay, then what? We need to. What happened to this answer? How are we adding? Yeah?
Add.
Yeah?
Equal.
Yeah?
1.
1?
No.
Why 1? What do we cache for? F what? We calling Excel, right? F what? And what? Come on. And what? Fill this blank, come on.
So return answer at the end.
Yeah, return answer, yeah. And
I think it's...
what are we doing here? Remember the climbing the stairs. This is the key point. Climbing the stairs.
No wait, I
I is the I what? We are currently in n, and there are a number of ways to collect. So what are the previous states of n?
N minus 1.
1? What is 1?
I.
Come on. Does it make sense? How high is that? How high is that, Eric? Okay. Okay, that's it for today.
Boy. Bye bye.
Bye.